Good morning, everyone. My name is G. Nikita, M. Pharmacy, Assistant Professor, specialization in the Department of the Pharmaceutical Chemistry. Today we are going to discuss about the diuretics. It is the second unit in the Medicinal Chemistry 2 subject of the B Pharmacy third year first semester. So in this we will discuss the introduction means what is the diuretics and what are the roles it plays in our body and general mechanism of action, classification, carbonic anhydrous inhibitors, thiazide, loop diuretics, potassiums, pairing diuretics, osmotic diuretics, structural activity relationship, structure, synthesis, adverse drug reactions and uses. So let's see what are the diuretics. So diuretics, it will increase the rate of flow of it will increase the urine flow and also the sodiums will be excreted from the body through the urine, and also it will adjust the volume of the body fluids, means it will increase the urine flow and also it will remove the sodium from the body, and also it is used to adjust the volume of the body fluids. So the normal fluid filtration in the human body is 180 liters. About 1.5 liters of the urine is formed in 24 hours. So the diuretics are concerned with the maintenance of the volume as well as the composition of the body fluid, means it is used to maintain the body fluids in the body and also removal of the sodium from the body. So it is used in the treatment of the several heart diseases like chronic heart disease and hypertension, glaucoma, acute mountain disease, and also in the pregnancy stage and hepatic disease stage. So for all this disease process, the diuretics are used to maintain the body fluids and also to remove the excessive sodium from the body. Next, general mechanism of action. So if you see here the general mechanism of action, the blood enters into the Bowman's capsule. So when the blood enters into the Bowman's capsule, it will get filters. After it will get filtration, it will enters into the glomerular filtrate. So here what will happen means the filtrate containing low molecular weight plasma components. So the fluid will enters into the proximal convoluted tubule, where the reabsorption of the sodium and carbonic acid, amino acid, glucose will take place. So here in the proximal convoluted tubule, the carbonic anhydrous inhibitor drugs will be active. So this carbonic anhydrous inhibitor drug, what it will do means it will stop or inhibit the reabsorption of the sodium and carbonic acid in the urine. So it will stop the reabsorption of the sodium and carbonic acid. So the remaining fluid or the blood in urine will be transferred to the descending limb of loop of Henle. So here the reabsorption of the water molecules will be occurred. So here in the descending limb of loop of Henle, the loop and the osmotic diuretics will be work here. The loop and osmotic diuretics drugs will be act on descending limb of loop of Henle and ascending limb of loop of Henle. So here what it will do means it will inhibit the reabsorption of the sodium ions, chlorine ions. Next, it followed by the distal convoluted tubule. So here what will happen means reabsorption of the sodium chloride will occur. So in this side, the thiazide diuretics drugs will be act to inhibit the reabsorption of the sodium chloride. Next, collect followed by the collecting tubule. Here what will happen means the reabsorption of the filtered sodium and the potassium ions exchange will occur. So here the thiazide diuretics will be act upon the collecting tubule. So finally the urine will be eliminated. In the urine the unwanted elements will also eliminated. See in a mechanism of action, the blood enters the Bowman capsule. So it will get filtered and it will enters the glomerular filtrate, and from the glomerular filtrate it will enters the proximal convoluted tubule. So where the reabsorption of the sodium and carbonic acid will takes place. So on the proximal convoluted tubule, the carbonic anhydrous inhibitor will be act so to inhibit the reabsorption of the sodium and carbonic acid. So next, it will enters the descending limb of loop of Henle and followed by the ascending limb of loop of Henle. So upon this two limb of loop of Henle, the loop and osmotic diuretics will be act to inhibit the reabsorption of the sodium and the chlorine ions. So next it will enter into the digital convoluted tubule where the reabsorption of the sodium and the calcium will takes place. So upon the digital convoluted tubule, the thiazide diuretics will be act to inhibit or the stop the reabsorption of the sodium ions. So next followed by the collecting tubules. Here where the thiazide drugs will be act in order to inhibit the reabsorption of the sodium and also exchange of the sodium and the potassium ions. So finally, in the urine the unwanted elements will be eliminated. So next, classification based upon the diuretic potency. So based upon the diuretic potency, first one is highly potent diuretics. So in this first one is loop diuretics. Examples are furosemide, bumetanide, taurusinamide, ethacrenic acid. So next, moderately potent or efficacious diuretics. So in this examples are thiazide diuretics. First one, in this examples are chlorothiazide, hydrochlorothiazide, hydroflumetazide and cyclothiazide. Second one is osmotic diuretics. Examples are mannitol and urea. So next one is weak diuretics. In this first one is carbonic anhydrous inhibitors. Example acetazolamide, midazolamide and dichlorphenamide. Second one is xanthine derivatives. In this example thiophyllene, aminophylline. So third one is potassium sparing diuretics. So example is spironolactone, triumphirin and amyloid. So next, so these are the classification which is based upon the diuretic potency, that is highly potent. In this highly potent loop diuretics, examples are furosemide, bumetamide and taurusinamide, ethacrenic acid. Second one is moderately potent. In this first one, thiazide diuretics, example chlorothiazide, hydrochlorothiazide, hydroflumetazide and cyclothiazide. Third one is osmotic diuretics. Examples are mannitols and urea. So next one is weak diuretics. In this first one, carbonic anhydrous inhibitors. Examples are acetazolamide, midazolamide and dichlorphenamide. Second one is xanthine derivatives, thiophyllene, aminophylline. Next one is potassium sparing diuretics. In this examples are spironolactones, triumphirin and amyloid. So next, based upon the mechanism of action. So first one is at proximal convoluted tubule. In this first one is carbonic anhydrous inhibitor. Examples are acetazolamide, midazolamide and dichlorphenamide. Second one is xanthine derivatives. Examples are thiophyllene, aminophylline. So next one is at the loop of Henle. Osmotic diuretics examples are mannitol, urea, glycerin, and isosorbide. So next one is loop diuretics, furosemide, bumetanide, torsemide, and ithacrenic acid. So next one is at the digital convoluted tubule in this thiazide diuretics. Examples are chlorothiazide, hydrochlorothiazide, in indapamide, anzapamide, metolazone, and bendroflumetazide, and hydroflumetazide, and cyclothiazide. Next, at convoluted tubules are potassium sparing diuretics. So here aldosterone antagonist example is spironolactone. Next, inhibitors of renal epithelial sodium channels is triamcinolone and amlodipine. So these are the classification which comes under the based on mechanism of action. Next one is based on the chemical structure. First one is organomercurial derivatives. So organomercurial derivatives. See here organomercurial derivatives. Here in R1 and X position, if we replace the different atoms means we will get the different drugs. So first drug is chlormirodin. So first drug is chlormirodin. So here in R position amino group is attached, and in R1 position methyl group, and in X position chlorine group is attached. So next drug is myrsalyl sodium. Myrsalyl sodium. So if you see the in R1 position, the sodium and carboxymethoxyphenyl is attached. See here sodium carboxy, COO is a carboxy, and here this is the methoxy, and phenyl is attached at the R position, and in the R1 position the methyl group is attached, and X position hydroxyl group is attached. So next drug is miralurid. Name is miralurid. If you see here in the R1 position, so in R1 position, the sodium amino oxobutanoic acid is attached at the R position. That is sodium amino oxobutanoic acid is attached at the R position, and in R1 position the methyl group is attached, in X position hydroxy group is attached. So next is phenoxyacetic acid. So next one is phenoxyacetic acid. This is a structure. If you see here in R position, if we replace the different atoms means we will get the different drugs. So first one is ithacrenic acid. So in R position, the ethylene butanoil is attached. See here in the second position ethyl group is there, and 1, 2, 3, 4. 4 carbon atoms are there means butane. So ethylene butanoil. So in oxygen is there. So ethylene butanoil is attached at the R position. And here in second and the third position the chlorine atoms are there. And in the first position the acetic acid is attached. So ithacrenic acid, here the ethyl butanoil is attached at the R position, means at the fourth position, and here in the second and the third position the chlorine atoms are attached, and here the acetic acid is attached. So next drug is quinone. So in the quinone drug. So here in R position, the 5-member ring is attached. The 5-member ring at the first position, oxygen is there. In the second position, methyl and phenyl group is attached. Next one is potassium sparing diuretics. In this first one, aldosterone antagonist. Drug is spironolactone. So this is the structure. In this structure, if you see that this is the pregnant structure. See here, 1, 2, 3, 4. Four fused rings are there. So this 4 fused ring name is pregnein. In the pregnein structure, third position oxygen group is there, and fourth position double bond, and 19th position and the 18th position methyl group is there. In the 7th position, acetyl sulfonyl is there, and in 21st position the carboxylic acid group is attached. See here, this is the structure of pregnein. In the third position oxygen group, and in fourth position double bond. In the 7th position sulfonyl acetyl group is attached. In 19th and 18th position the methyl groups are attached. In 21st position the carboxylic group is attached. So next one is aminopyrazine. A drug is amiloride. Drug name. So this is the structure of the amiloride. If we see here, this is the structure of the pyrazine. See here, 6-membered ring. In the first and the fourth position, the nitrogen group is attached. So it is a pyrazine. In the 6th position, fluorine atom is there. In the third and fourth position, amine groups are attached. In the second position, carboxamide is attached. See here, this is the pyrazine structure. Second position, carboxamide group is attached. In 6th position, fluorine, and third and 5th position, amine groups are attached. So next one is pyridine. So drug name is triamterene drug. So this is the structure of the pyridines. So in the second position and fourth and the 7th position, amine groups are attached. In the 6th position, phenyl group is attached. See here, in the second, fourth, and 7th position, amine groups are attached. In the 6th position, the phenyl group is attached. Next, carbonic anhydrous inhibitors. So in carbonic anhydrous inhibitor, first drug is acetazolamide. So if you see the structure here, this is the thiazole. In first position, the sulfur group is there. Third and fourth position, nitrogen group is there. So it is thiazole. And here in the 5th position, the sulfonamide group is attached. In the second position, acetamide group is attached. See here for the thiazole structure. In the 5th position, sulfonamide. In the second position, acetamide group is attached. Next drug is methazolamide. This is the structure of the this is the structure of the thiazole. In the 5th position, sulfonamide group is attached. In the third position, methyl group, and in the second position, acetylamide group is attached. So next drug is dichlorphenamide. So here this is the phenyl structure. For the phenyl, in the 5th and 6th position, the chlorine atom is attached. In the 1st and the 3rd position, the sulfonamide group is attached. So next, benzothiazepine. In this first one is thiazide diuretics. So this is a structure of the thiazide diuretics. See here structure in the 3rd position and the 6th position. If you replace the different structures means we will get the different drugs. First one is chlorothiazide. In R1 position, that is 6th position, chlorine atom. In R1 position, hydrogen, that is 3rd position. Next, benzthiazide. In R position, chlorine atom. In R1 position, benzoyl sulfonyl methyl group is attached. Next one is flumethazide. Here, methyl trifluoromethyl group is attached in the R position. In R1 position, hydrogen group is attached. So next, hydrothiazide diuretics. So this is a structure in R1 and R2 position. If we replace different atoms means we will get different structures. For example, first one is hydrochlorothiazide. In R position, hydrogen, R1 position, hydrogen, and R2 position, chlorine atom is attached. Next one is bendoflumethiazide. Bendoflumethiazide. So in R position, hydrogen. In R2 position, the ethyl and phenyl group, ethyl and the phenyl group is attached. In R2 position, trifluoromethyl group is attached. So next drug is hydromethazide. Here in R and R1 position, hydrogen groups are attached. In R2 position, trifluoromethyl group is attached. Next, methyl chlorothiazide. In R position, the methyl group is attached. In R1 position, the methyl group is attached. And in R2 position, the chlorine group is attached. So next drug is polythiazide. Here in R position, the methyl group is attached. In R1 position, so in R1 position, trifluoroethyl sulfonyl is attached. Trifluoroethyl sulfonyl is attached. In R2 position, the chlorine atom is attached. Next one is trichlormethazine. So in R position, hydrogen group is attached. In R1 position, the dichloromethane is attached. In the R2 position, the chlorine atom is attached. Next, thiazide-like derivatives. In this benzhydrazide, first drug is indapamide. If you see here structure, this is the phenyl. For the phenyl in the 3rd position, the sulfonamide group is attached, and here the chlorine group is attached, and here the carboxyl and amide group is attached. So to this amide group, the indole structure is attached. To the indole, at the 2nd position, the methyl group is attached. So next, tetrahydroquinozolene. So this is the structure of the tetrahydroquinozolene. And here in R and R1 positions, in 2nd and 3rd position, if we replace the different atoms, means we will get the different drugs. So here first one is quinidazone. So first one is quinidazone. In R position, the ethyl group, and in R1 position, the hydrogen group is attached. So next one is methalazone. So methalazone drug. Here in R position, the methyl group is attached, and in R1 position, the methyl phenyl is attached. The methyl and phenyl is attached in the R1 position. So next drug is chlorothiazidone. So chlorothiazidone, if you see here structure, this is the 6-membered ring. First six-membered ring. In the second position, the chlorine atom. First position, thio. Means in the first position. In the first position, the sulfonyl group is attached. In the fifth position, the indole structure is there. So, at indole structure at the first position, hydroxyl, and the third position, oxygen group is attached. So, next one is high sealing or loop diuretics. First drug is furosemide. So, here this is the furon and this is the six-membered ring. For the six-membered ring, here in the fifth position, the sulfonyl group is attached, and fourth position, the chlorine group, and in second position, the amide and the indole structure, furon structure. For the furon in the second position, the methyl group is attached. So next, bumetanide, and this is the six-membered ring structure, and in the first position the carboxylate is there, so it is known as benzoic acid. In the fifth position the sulfonamide is there, and in the sixth position phenoxy group is there, and in third position butyl amino group is there. Fifth position sulfonamide, and fourth position phenoxy, and in third position butylamine group is attached. So next drug is torsemide. So in the first six-membered ring, in the third position the methyl group, and here the amide group is there. Here the pyridine structure. The pyridine structure in the third position, the sulfur group and the urea and the propane structure is attached. So see here in the third position methyl, and here amide, and this is the pyridine structure. And for the pyridine in the second position, the sulfur group, and this is the structure of urea, and this is the propyl structure is attached. So next is miscellaneous. In this xanthine derivatives, this is the structure of the xanthine. In R and R1 position, if we replace the different atoms, we will get the different drugs. First one is caffeine. In R position methyl, R1 and R2 position methyl group is there. If we replace means we will get the structure of the caffeine. Next, thiophylline. In R and R1 position methyl, and in R2 position hydrogen group is there. Next, thiobromine. In R position hydrogen, in R1 and R2 position methyl group is there. So next, osmotic diuretics. First one is mannitol. See here, 1, 2, 3, 4, 5, 6. 6 carbon atoms are there. For these 6 carbon atoms, in the first, second, third, fourth, fifth, and sixth position, the hydroxyl group is there, OH. And here in the second, third, fourth, and fifth position, the hydrogen group is attached. See here, 1, 2, 3, 4, 5, 6. 6 carbon atoms. For 6 carbon atoms, the hydroxyl groups are attached. In second, third, fourth, fifth position, the hydrogen group is attached. Next, urea. This is a structure. The 2 amine groups are attached to the carbon and oxygen atom. Next, isosorbide. Here, this is the structure of the D-gluticol. For the D-gluticol in the second and the sixth position, the two hydroxyl groups are present. So this is the classification which comes under the diuretics. First one is based upon the diuretic potency. Next one is based upon the mechanism of action. And next one is based upon the chemical structure.